Thank you very much for the introduction. I have to apologize, but I have my slides in Portuguese and some in English, but I didn't know that. But don't worry, I will try to say everything in English with some words in the middle in Portuguese, but don't worry. So my idea on this seminar was to try to find one of my last problems that I have using data from COVID-19 and try to show all the process we have. So the idea is clean, tidy, explore, analyze, discuss, and communicate data. And the idea is to transmit the application to COVID transmission and case fatality in long-term care facilities. So everyone remembers that in the middle of August or June of the previous year, that we have a lot of news about, we have a lot of deaths on COVID, on, how I say, residential for older people. So I will call RP, the name for that. And we'll have specific RPs that have a lot of deaths. We saw that and we wanted to know, in reality, the real question we wanted to know was to know if these were the usual prevalence compared, the expected prevalence compared to the population, if the mortality or the fatality cases were the expected values or not. So the information was very scarce. We didn't have any information. So we tried to make a task force, if you want, working with all the healthcare units of the North region, or try to contact all of them. In a few meetings, we tried to do an Excel file, if you want, with a few very small number of variables, because we wanted to have a fast answer and answer that, and that we could present this in our InfarMed meetings and so on. Professor Enrique, that is my boss, was always there, and we needed to take information that was collected in a scientific way and very analytical to show to the politicians. So we tried to do this, we make that, but as usual, although we did give a data file, we give the instructions, everyone is very creative in the way they collect the information. They always try something that we don't expect. We use Excel if you want, because it was the only software that they have, if you want, in the health units they work, so needed to be like that. We didn't have time to create a, I would say, a formulary. Everyone have different things, so we have that. So the first problem as you work, all of you already have seen some kinds of these schemes. We needed to clean the data, we needed to transform, to look to the data, visualize to see if there were mistakes or not. And finally, we needed to do a model, interpret the results, and discuss that with communication, if you want, with everyone. So that was the idea. And so this data science process that we have in this scheme is exactly what we needed in this example. So we needed to import, we needed to tie, and I will try to find where we did, what we did in each step of this scheme, that all of you know this scheme, so I will try to show that. So what are the first idea that I want to transmit? This data was dynamic. They show us the data, we have a data set, then we find a mistake, then we change again the data set, then we find another mistake, they give another data set, and so on. So in this type of science, we need to have a kind of language that allow us to repeat the process a lot of times. So one of the advantages of not using programs like, if you want, SPSS, or something that is not have that idea of reproducibility of the analysis we are doing, is very hard to do it like that in SPSS. So softwares like R, Python, or something that allow us to program, that have a language of programmation, allow us to control more this type of repeated analysis because of mistakes. So we have a more reproducibly analysis. We have a kind of automation of that allows us, as I said, to copy paste from other codes and so on, and allow us to communicate to others what we did. So this is the main advantage of using softwares that all of us use in data science to allow us to have this advantage. I use R, so many of you maybe use R, others use Stat or something, or Python or so on. The advantage that I always say is open source. There is a lot of packages with a lot of tools that allow us to have a very careful analysis. And also they are a very active community that if you have doubts, if you answer them, they always will give the answer to that and tries to help us to do our analysis. So that is one of the advantage. And we always can do our own analysis by doing our own program in R. So that are the advantages. What are the disadvantages of using this? As if it's someone that works with, but will say that this is a language that is relatively slow in terms of calculation and so on. Usually it's not really for big data. They allow us like 1 gigabyte of, they work well. If you have 1 million of observations, if you want or not, work well, but they have libraries that allow us to have more, like data table and so on. So if you have a big data, maybe we'll need to aggregate the data, split the file or so on. So it's not really for big data, but at least is enough for this type of analysis. So I put here some of the packages I use. Usually I use data tables, string R, lubridata to control data, ggplot. I use per to control lists. If you want to do a markdown, I use knit-R. So also dplyr if you want to have a language that everyone understands, or tidyr. This is a few of the packages you can have in R that you can use to do cleaning and tidy the data. I put here, usually our cleaning is always about some operations, and dplyr, for example, has a command for each of these operations. Usually we want to do a kind of selection of rows of observations, or we want to select variables or columns. We want to construct variables or use mutate. If you want to ranking the variables in some order, use arrange. We want to summarize, that is the idea of statistics, so use command summarize. You can do stratify analysis using the group by or row wise. And if you want to connect a lot of data sets, you can use bind calls or bind rows or join and so on. So this package, if you want, is a kind of summary that tries to simplify R if you want. So R is not a specific language for statistics. It can be used for other things. So when people says R is a software for statistics, is wrong. It can do a lot of other things, and there is no particular package or something that do statistics. So you need to, within the base of the software, there is nothing specific of statistics. But if you go to some packages that are created to have a more specific statistics, you have this one like dplyr that controls a lot of things. So what are usually the major problems when I have a messy data? The first one, we have a lot of data sets, if you want, a lot of information for several places. So we need to join that. The second one, we have in one column, in one variable, if you want, a lot of data from different units, if you want. We can have numbers, strings, you can have some things in kilograms, others in grams, and no one separates really the data like that. The other things, we can have in one variable, if you want, one column, several variables. So we need to, in some way, separate that variables. And finally, usually when we work with datas and times, usually we have problems because the data are from different places and different, how I say, time hours, and we get a lot of troubles to get the data from this messy. So I'm going to show that these example that I have here have a lot of these things that I have to show. So first, I try to import the several files from the else unit. So we have 8 else units that you can see here, if you want. So I wanted to, in some way, aggregate this information in one dataset and clean dataset. What was the first problem? One of the ones that usually happens is that we go to the data, we see the first file as like 6,000 lines, and we look that the file don't have that number of lines. The file in reality has 1,000. So what happens? That when they were insert the data in Excel or so on, they created blank lines. So we need to do a command that cleans the link line, the blank line. So we did it like that. Another thing that always happens when we have a lot of, I always say, else units working with us, they don't identify the, if you want, the unit. So we need to create a variable that says this is for data from this unit or from another unit. So you need to say that. And finally, usually they create another variables that we didn't want it. So we needed to select the variable. So we have here a kind of example that shows some of the problems. So we needed to select the lines, we needed to select the columns, and so on to create the final data set, and then aggregated the 6 files. So if we aggregate the 6 files that I have, 8 files that I have there, we go finally to the transform. So the idea of creating new variables, clean data. In reality, will be a connection between these two. So this is the first one. This is this file. Because we wanted to compare with the population data, what was the fatality rate, what was the infection rate from the residents, if you want, from the residents from old people. We wanted to compare that. We needed to compare to the population. So we go to another data set that is one from the national, if you want, DGS. It's easy to say in Portuguese. The DGS as the file that sends to all faculties and so on, that has the age of everyone. And in the beginning of COVID, this was like this. So you have data that was in days, data that was in months. So the age was in years and months and so on, depending if it was a baby or was something else. So we have this. What I want is a variable that has the age in years or in months or something. I need to have in the same unit. So that is one of the problems. So I needed to go to here, do something like reading the days, reading the text if you want. I read the text, and if it was written days, I would divide it by, if you want, the number by the number of days in the year to have in years. If it was written years, I needed to divide, only transform in a numeric number, if you want. If it was in months, I needed to divide by 12. So I needed to clean this, if you want, this variable in a simple way. And we did finally a summary of this information. And if all of us remember, this was a data set that was not clean. It was very fast, but delivered to everyone. So as you can see, we have people with age of 134, and that was a mistake. Something of the age was wrong. Maybe it was 13, maybe it was 34, we don't know. So imagine this is the real example that even in the data set that comes from the government, if you want, in some ways, is going to have these mistakes. So you need to be very careful here. Secondly, in the data that we give to the else units, we wanted only the first result of the diagnosis test that was positive. And someone, no, I'm going to give all the dates. So they did like this. They say the first result was positive, the second result was positive, the third result was negative. So you give all the information. If you want, when he gives these tests, the ones that were not in text Excel, when passed to R, will transform this in the number. So we get a very messy data here. So we needed to separate these and then arrive to what we wanted. So first, I needed to separate. So tidyr as a command that is separate rows. And you can see here that it separates every comma, everything. And you can see here how we separated this. But this is not what I wanted. I only wanted the first one with a positive, or if all of them were negative, I wanted, if you want, the last of them of the negative values. So I needed to aggregate this information. So I needed to use from this transform to the first one. And that was what I did. As you can see here, I separated, then was selecting the first one, and then selecting the one that was with 1 and the other ones was with 0. So is what I did here, doing this. So finally, I arrived to what I wanted. I wanted only the date of diagnostics for the ones that were positive and the date of the last test if they were 0. Okay, but then we have that problem. There were dates that were numbers and dates that were texts, if you want. So I needed to some way transform that. So what I needed is to transform everything, and that was exactly what I did using Lubridate to transform, if you want, everything in the number that I wanted. So you can see here an example that we wanted to have fast analysis, we wanted to arrive to the results, but we needed to do everything like this. And then finally, we go to the part that we like more, starting to find the patterns, starting to visualize the data, and so on. And then usually we try to do, and I'm going to distinguish two things. The first graph I usually do is a very not using the base code of R. And this is a graph that is only for exploration, if you want. And then we need to communicate that. And then, so you need to separate these two entities. We want a graph that's only to explore the data, and we want a graph that's going to be displayed and communicate to the world, if you want. So this is the difference, if you want. I'm going to show the same graph. This is not from the same data set. What we have here is the, if you want, the epidemic curve on January. Okay. And you can see here that for the base code is very simple here in January. But if I want to use a very beautiful graph using ggplot, the code is this one. I only show to show the difference. And we get, this is the same graph, but a much prettier one, if you want, to show in the meetings of InfarMed and so on. So you can see here in this, for example, we wanted to know if the schools were having an effect, the close of the schools in January, and the close of the, how I say, of the shopping centers and so on, if this has an effect. And you can see here that here in the data of 50th of January, we close, there is a lag to obtain the results. We calculate in the way we were doing that, this was about 12 days. And you can see we started to diminish like 5 to 6%. And then when they close the school, the same lag, if you want, 12 days. And you can see that when we close the schools, we started to go very much faster in terms of diminish the case. So you can see here, this was trying to show the difference of a way of doing the things to explore and a way of showing these in the public to have a more appealing results. You also can do other things. With R, you can do shiny apps, for example. For example, one of the things we use a lot, if you want, is so we have data every day. My boss wants to know if you are slow, diminish, or increasing, and so on. So we created an app that he has access, and we can show. I can show here. I'm going to stop my presentation for 1 minute. Go here. Maybe it's easier. This is a personal, though it's not for use for the public if you want. but if it don't takes too much time, I don't know if my connection with Zoom and so on is very fast. But the idea is I created this for my boss to see, if you want, how was the evolution in the North region at this moment, what is in terms of deaths, if you want, in the North region, how was the hospitalizations, and say, so you can do this in our Shiny app that we can be very dynamic. We have here the duplication time. We have here how are our prediction for the next 15 days, not 7. So I didn't change this. But the idea is we can do a lot of things when we are visualizing. If you are very successful, sorry, I need to compartilhar a tela outra vez. Sorry. Okay. Sorry again. The problem is I have here. Okay, now I can do it. Okay, so you can see if you are very successful doing this kind of visualization, we can have like something in the public with this is the same Shiny. They ask us to give the predictions for their journal, and we arrive to this kind of publication in the journal. So it's possible if they like a lot of our tools to do this. Another things we can do for visualization is doing animated things. You can see here in this case that we try to rank Portugal in terms of deaths for 1 million of inhabitants. And you can see along the time is by week that Portugal was in the middle, if you want. And then let's stay till January. Everyone already knows this. I should have put this more faster, but don't worry. We are in the middle. Portugal was in the middle of the ranking. And then when I go to January, as you can see, the number of deaths will start to increase and we'll going to first here. You can see, so Portugal now was the first, where all the news saying. So we can create all these type of visualizations using R, using GG Animate to give a more clean approach, if you want, to the results and to explore the data. In this case, I wanted to see what was the ranking, what was the evolution along the time between the countries. So we try to create this type of visualization that is possible to do using R. Finally, if you are very bright thing, you cannot do in R. Maybe you can, how I say, hire a designer like this, and the designer created this graph. You can see here, this was in the beginning, this of the COVID-19, and you can see that they do very, very beautiful things. You can see here the survival graph plot that he did, like here showing the scale was cut here, if you want. Then we cut for this part and show what was the survival percentage for each age. So you can see that we can do things in R, we can do Shiny apps, and we can ask a designer to create, if you want, a very beautiful, how I say, image and graph and plot. So finally, so the graph serves as to several things. The first thing is to find the pattern. So the first pattern for data we wanted to work here, from all that 8 health units, we arrived to 3,000 individuals, and 70,000 was residents on the nursing homes, and 60,000 was workers there. So we wanted to see first if there were differences in ages that we expected to happen, and that's happened. So the residents are very much older compared to the ones that are working there. But you can see that there are some persons that are almost in the same age. And the major idea here is these age structure is different from the population. So we cannot compare directly the prevalence and the letalidad in Portuguese of Portuguese compared directly to the letalidad and the infection rate from these 2 samples. You can see here that we try to separate these by different healthcare units, and we can see that the percentage of people that were infected was very different between the several healthcare units. As you can see, there were some of them that 30% of the population already have infection, and others that have 0.3% at the moment that we did this. So you can see there is a lot of difference here between here, and then we go to the results and look to when there was a case in one particular nursing home, if there was a lot of difference, what was the percentage, if you want, of people that get infected. And you can see that there were RPs and nursing homes that arrived to 100%. Everyone gets the COVID-19 infection, and there are other ones that didn't pass off 0.3% of that nursing home. So there was in reality didn't have a big case there. I don't know the term in English, but don't worry. So we did this. Then we look to the mortality, and within the mortality within the cases was very different. We have, for example, in one unit about 50% that were dying, and the others like Porto Oriental that 38.8% has died. So we have difference between assays. In the case of the working people there was no case fatality. So here we decided, so we cannot study the mortality and the fatality cases, mortality in the case of the working people. So we only study in the people that were in that RP living there. So we see these, we visualize the data, so we decided we don't study these and we discarded 2 health units because in reality only give the case, didn't give the people that didn't have the infection. So we only have 6, and we try to do not a real model if you want, but we try to see adjust for age. The only variable you wanted, if you want, was a mistake of us. We only ask to be very fast to give us the date of birth, the date of the infection. So we have the age. We didn't ask to have the gender of the person. So because of that, we didn't adjust for gender, but this is because we want the data very fast. So we forget to have the gender in the data set. So we didn't get that. So you can see here that in the moment that we did the study, this is between March and June, the cases between these, in reality, we can see that for older age, the incidence was much higher compared to the other ones. Although, as every one of us knows, these in reality are the cases that were detected. Okay, we know for example, that for each case that is detected in the first phase between March and June, maybe 3 or 4 cases were not detected. So and that was much higher in the younger age because they are asymptomatic. So we need to be careful. This is a limitation of this study. We need to look to this and see if this can be considered the incidence, if you want, for each age. In March and October, that in this moment, if you want, that the tests are more, and the ratio is now maybe 1 to 2 and not 1 to 3 cases that were for each detected. So we did this and we compared. So if you want, you can see here the numbers for the numbers expected, if you want, calculated using group ages, if you want. We expect to have about 60 cases of infection, if you want, in this group, and we get 80 cases. So if you want, the expected value was 1.4 times higher compared to what was expected for the group of elder people. For the group of workers, if you want, these we expect to have 40 cases and we have 86, so 2 times higher compared to what we want, what was expected, sorry. So you can see this was significant if you want. to see that. But the idea was, we see that in reality there was 2 times higher cases in the nursing homes, okay, for the workers, and 1.4 cases for the ones that were in the residence, living in the residence. When you look to the fatality rate, if you want, we observed 53 cases. What was expected was about 35, 36. So about the same number as the previous one, about 1.5 times higher compared to the same age people. Okay, so that was the idea. We wanted to know what was the number. And then we did another thing. The idea of this study, to have the data of symptoms, the data of testing and so on, was to calculate the R0, if you want, for each nursing home, to understand if the different conditions in the nursing homes allow us to have better results in terms of protection. So if the R0 was lower in some nursing homes, that were the ones that have better conditions compared maybe to the other ones. So we tried to do this, but the problem is the first one. They almost, I didn't show here, but we have a lot of missings in terms of data of symptoms, so we didn't have that. And what happened is that when 1 or 2 cases were there in the nursing home, they go there and test everybody. So everyone is in the same data. We don't know in reality if that was first or second. So there is another way of arriving to R0, that is trying to know what was the proportion of not infected. I put here some formulas if you want to understand this, but the idea is the final number depends on the R0. So if that, we can calculate from the final number of proportion of cases, what was the R0. And you can see here our several estimates that we did, and it ranges between 2.4, 2.3, and in some cases, the ones that didn't get very cases was about 1. So if you remember, I don't know if you know that, but in the population in the beginning, the numbers that we're talking in Portugal was between 2 and 3. So this means that the nursing homes was in at least in the same level of transmission rate within the nursing homes. So you arrive here, we have this information, we need to communicate this. And that it gets a lot of trouble. When I do an article, we don't get a lot of troubles. We respond to the reviewers of the article, and it's not a problem. When we communicate to the, if you want, to the journalists and so on, and to the public, that is another game, if you want. You should have a few rules, if you want. The statisticians, they should not talk as a statistician. She should not talk about p-values, confidence intervals, magnitude of effect, or so on, because they don't understand that, okay? So usually they don't like that. And also, we are usually very critical about how it works, and we see all the limitations, and we want to say what are the limitations. But that sometimes is, I would say, noise in the communication, and the people will treat us like that was not working well. So, and that happens to me, not in this particular case, but is the idea. And another thing you need to know, they want that knows that we need to know every number by head. Every number we need to know. They expect that for us, so you need to know that. So you should have a few rules to communicate. I'm going to show here an example of not that work, because we published that like 1 month or 2 months here, but we communicate in the previous first. So, but that is the first mistake. Because it was COVID, we needed first to communicate the information to the politicians, decide the reason, decided we using evidence base, and people attack us because we didn't publish that. So this is the case. If you remember, that was if you remember, there was very many people saying that there were problems in the lines of the train lines in Lisbon in June of the in 2020, and that was the reason why there was a lot of cases in that topic. And we didn't have information. We don't know if there is no data set saying these people was in the train or was not in the train. There is no information about that. We try to see also, we're going to surrogate this in a kind of way, saying ecological study, and try to see if the people that are living close to the lines that maybe will use more the train lines will have a higher rate of infection. We did this to have at least some information, and we arrived to results that in reality this depends on the line and in time. For example, in March, the line the region that was close to Cascais, where the region there that close to that line was the one that have more risk. But when we go to April, May, and June, the region that gets more cases were close to the line of Sintra. So you can see there was an interaction, if you want, between the regions, time, and the line they were close. So we said maybe the reason is not only for the train, and we get a lot of troubles here. The ministry interpreted this saying there was no risk in the using trains. I needed to go to explain to the journal that was not what we said. So very difficult to talk about with the communication. And then I said, we're going to do a case control study, that we're going to ask to cases if they use the train or not on public transportation. And in the controls also, we asked the same thing. And you can see here that in reality it was not very different. We find here, if you want, 1.4 for the line, but then when we go to the case also, we find 1.4. But when we adjust for age, education, and if you want education income, this disappears, meaning that maybe this was confounded by the people that use trains, have different jobs, different say. So the problem maybe is not in the transportation. So we get a lot of troubles when we are communicating, and that was the idea I wanted to show here. So this is the same. We show that were 2 times more risk, if you want, to infect from the people that work there. So we could be interpreting, if a journalist could interpret this, saying, so we are saying that in reality there is a problem in the nursing homes. But that can be, but that is not what we show. We show that, but we need to have in account that I didn't have in account the gender. I didn't have in account that maybe there are more testing the people that works in the nursing homes compared to the population. So we need to write that in the article to explain that although we find 2 times higher than expected the number of infection, or 1.4 if you want of fatality rate of expected, that can be from different regions, and the data I have didn't have that information. So you need to be very careful, and this is what we write in the article. So as you can see here, this is, I'm finished, almost finished. I'm saying here that, as you can see, the process is very slow and is much slower compared to what the information, the communication, the public communication wanted. We needed to clean the data. We need to import the data. We need to do the analysis, see the part of visualization of the data, decide to eliminate maybe some part of the information because we didn't have good quality and so on. We interpret the results, and then we need to communicate, and that is a different job. We need to do a different visualization. We need to do communication maybe with the different rules that we are expecting, and that I wanted to say, saying that we need to add that to the communication, that there is a different game when we do this. And that was what I wanted to show today, a very clean example of what's happened with data and so on. Okay.